Today we're learning how to calculate the distance that a point is to a line. Question 1, we're determining the distance from the point A, which is at 1, 3, to the line y equals 2x take away 4. But first of all, we need to know what we mean by distance. By distance, we mean that we are trying to find the shortest length between point A and the line. Now, when we mean shortest distance, we know that the shortest distance always goes or meets at a right angle to the point in or to the line in question. So think of the wall holding the chalkboard as our line, and we're the point. And if we want to get to the chalkboard using the shortest distance possible, we want to head in a direction that is perpendicular to the chalkboard. So if we didn't hit it at a perpendicular angle, like at a 90-degree angle, our distance won't be the shortest. We're going to be taking longer than we need to get there. So when we're calculating this, the shortest distance will go from the point, which in this case is A, to meet the line at a 90-degree angle. So that's an important element that we need to know when we're doing these questions. Okay, so when we want to determine the distance, we have to follow three steps really here. And I'm just wondering if I can change the color in which I'm typing in. I think I just did. All right, the first step, nope, I clearly didn't. Maybe I need this button. We'll try this. All right, the first step is to get the equation, there we go, of the line through the point, so in this case it's the point A, which is at 1, 3, that meets the given line at 90 degrees. So that is our current goal for step number 1. There we go. Get the equation of the line through the point A that meets the given line at 90 degrees. Okay, step number 2, after we get that line, we need to find the intersection point of that line we found in step 1 and the given line. So if we want to find the intersection point, we know we might need to solve this system. Oh dear. Here we go. Find the intersection point of the line found in step 1 and the given line. All right, so we're going to be solving a system. And then step number 3 is to use the distance formula. Use the distance formula. With the point found in step 2 and the given point A. I love autocorrect. Sometimes. All right, use the distance formula with the point found in step 2 and the given point A. So that's our third step. So down below here, we are actually going to do these 3 things. Okay, so let me flip to the new slide. We know that step number 1, we need the equation of the line that goes through A. Point A is at 1, 3. So A is at 1, 3, and it has to be perpendicular to the given line. So we need to be perpendicular to y equals, the given line was y equals 2x take away 4. So this one has a slope of 2. The slope that we need, the slope that's perpendicular, would be negative 1/2. So we need the slope of negative 1/2 and a point of 1, 3. So if we put that into y equals mx plus b, we know that our m is a negative 1/2, and then we can take the y from our coordinate point A, which is 3, and the x from our coordinate A, and then we can solve this equation for our b. So 3 equals negative 1/2 plus b. I'm going to add a half to both sides, so I'll have 3 plus 1/2, or 3.5. 3 plus 1/2, or 3.5, would equal b. 3 wholes would be the same thing as 6 halves plus 1/2. So b is equal to 7 halves. So my new equation, or my equation of the line, would be y equals negative 1/2 x plus 7/2, 7 halves. Okay, from there, step number 2 would be to find the intersection point of our two lines. The first line being the one that was given to us, y equals 2x minus 4, and the line we just found, which is y equals negative 1/2 x, meets it at 90 degrees, plus 7 halves. Okay, equation 1 and equation 2. These are both solved already for y, so it makes sense that we can sub equation 1 into equation 2 and solve by substitution. Okay, you can solve by elimination if you prefer, but I'm just going to use the method of substitution here. Now I've got fractions with a denominator of 2, so what I'm going to do is multiply everything by 2. So I'm going to times by 2 to eliminate my fractions. And when I times by 2, I'm going to end up with a 4x minus 8 equals negative x plus 7. And then I'm going to add x to both sides, so I have 4x plus x, and that's equal to 7. And I'm going to add 8 to both sides to undo the minus 8. That leaves me with 5 x's being equal to 15. Divide both sides by 5, x will equal 3. So there's my x coordinate for my point of intersection. I'm going to sub that into the given equation. So sub x equals 3 into 1. And then I'm going to get y equals 2 times my x, which is a 3 minus 4. That's going to be 6 take away 4, which is 2. So 3 comma 2 is our point of intersection. Now the last step here is to find the distance between that point of intersection, which is 3, 2, is the intersection point. Okay, so now we want to use the distance formula using this 3, 2 along with our point A, which is 1, 3. Okay, so distance formula. We've got point A, which is at 1, 3. We've got our other point, which is 3, 2. We know that distance is equal to the square root of x2 minus x1 squared. So that's our run squared plus our rise squared, which is y2 minus y1. It's based on our Pythagorean theorem. That's going to equal the square root of, I could do 3, my x2, take away the 1, my x1 squared, plus y2, which is 2, take away the 3, which is my y1. That's all squared. That's going to equal the square root of 2 squared plus negative 1 squared, which is equal to 4 plus 1, all squared rooted, which is the square root of 5. So my distance, that's approximately equal to 2.24 units. My distance between the point A and the line is about 2.24 units. Therefore, point A is about 2.24 units away from the line. And there we have that question.